Determination of a protocol for bovine trachea cartilage decellularization for tissue engineering application. My name is Laís Lopardi Leal and I'm a master student. Tissue engineering consists of techniques for recover living organs and tissues, in addition to restoring and maintaining its normal function by recruiting patients on cells that are cultured in biological or synthetic substrates, called scaffolds, for later insertion into the patient. Therefore, tissue engineering consists of an essential triad: stem cells or progenitor cells of the tissue of interest, a biocompatible and biodegradable scaffold that support adhesion, migration, cell proliferation and differentiation, and signaling proteins as stimulus for differentiating cells. Tissue engineering uses three classes of biomaterials: natural polymers, such as collagen, hyaluronic acid, fibrin, alginate, agarose, and chitosan, extracellular matrix without cells, and synthetic polymers, such as polyglycolic acid, polylactic acid, and their copolymerizations. In order to choose a synthetic scaffold, it is necessary to take into account the location of the implant, chemical composition, morphology, porosity, among other factors that influence the inflammatory response and the rate of degradation of these scaffolds. Research has been reported for total or partial replication of human tissues or organs using synthetic scaffolds. Although studies show that synthetic scaffolds do not adequately recover the native microenvironment and are often not specific to the damaged tissue. Therefore, scaffolds of biological origin are the most indicated and most used in recent research for tissue engineering, turning the attention to the natural polymers and to the decellularized extracellular matrix, referring to the damaged tissue itself, once they are tissue-specific and mimic more precisely the extracellular environment. Therefore, the ideal material for bioengineering must have anatomical, morphological structure, and chemical and biological signs similar to the tissue to be repaired or restored. Extracellular matrix scaffolds are produced by cellular content removal process with minimal loss of constituents. In the literature, 5 categories are described for extracellular matrix decellularization procedures. 1. Physics, by cycles of freezing and thawing, pressure, sonication or stirring, in which the choice of method is dependent on the composition, volume, and density of the tissue. 2. Chemistry, by the use of buffers, non-ionic or ionic detergents, acids and bases, or chelating agents. 3. Enzymatic, that degrade specific cellular components. 4. Protease inhibitors. Once protease is released during decellularization, can damage the extracellular matrix. And 5. Antibiotics or decontaminants, to avoid microbiological contamination of tissue that has undergone extensive decellularization protocol. To determine whether the decellularization method is efficient, certain criteria must be observed: absence of cell nucleus in the histological analysis with hematoxylin and eosine or with DAPI, DNA quantification less than 50 nanogram per milligram of dry tissue, and DNA fragments less than 200 base pairs. After decellularization, these scaffolds is recellularized with stem cells or progenitor cells that may be from the patient himself. Thus, the aim of this study was to determine a protocol for the cellularization of bovine trachea cartilaginous tissue with minimal loss of extracellular matrix. Thank you.